gonna stop till I see the light. I'm feeling high, my little lady. I'm gonna take it to the other side. You know I used to smoke too much. You know I used to drink too much. Take a ride in my car. You can get me high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car. We're gonna get real. Oh, I'm feeling good. My little lady, she's gonna take me to the other side. I'm feeling nice, my little lady, she's gonna keep me moving on. I'm gonna run till I drop to the break of dawn. Never gonna stop, she's gonna treat me right. I'm feeling good, my little lady, she's gonna take me to the other side. You know I used to smoke too much, and you know I used to drink too much. Take a ride in my car, and you can get me high, high, high. You know I used to smoke too much, and you know I used to drink too much. Take a ride in my car, and we're gonna get real. Come on, baby. Let's take a ride. I don't know where we're gonna go, but first, let's dance. You know I used to smoke too much, and you know I used to drink too much. Take a ride in my car, and you can get me high, high, high. You know I used to smoke too much, and you know I used to drink too much. Take a ride in my car, and we're gonna get real. Oh.
Hi everyone, Dan here, and I just wanted to put a little snippet about AstroWorld and what we do because I want to start getting the word out because I think it's becoming more and more of a giant community, and I want to get the word out to some other people. So what we do at AstroWorld is we hold astrophotography chats on Wednesdays at 9 p.m. and Fridays at 8 p.m. Eastern Time. And we just talk astrophotography. Wednesday's more of a techie kind of advanced intermediate, and Fridays is more of a newbie kind of thing. So if you want to check us out, and if you want to, hang out with some semi-decent people that like to go off the rails a little bit and have fun while they're doing it, come check us out at astroworldweb.com, and you can check out the schedule, and you can sign up for all the free giveaways that we do. We just gave away an Eagle 4 Pro, an Optolong filter kit, Charles Brackenstein's books, and a whole bunch of other stuff. So come to astroworldweb.com, hang out with us, have a good time, and as always, remember to keep imaging, keep educating, and clear skies. And I'll see you soon. Bye-bye.
Intense. I rip my jeans on your fence, hiding away from your man. Oh, it's a passion. Oh, tell a tale of 1,000 lonely days. Yeah, she's a real thing. Yeah, only I can make a change if you want to be together. getting caught in the rain, standing here calling your name. Guess I got no one to blame. Yeah, it's a small town. Yeah, all the people turn and stare. Oh, it's a secret. Hey, let them see me. I don't care if you want to be together. It's so good to be together with you. If you want to be together. If you want to be together, it's so good to be together with you. If you want to be together, say you want to be together. I'm feeling really guilty, but it feels so bad. Yeah, so good to be together. We did it before, and we can do it again. I'm tearing out my hair, 'cause I don't know when. So good. You want to be together. Yeah, 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 yeah. It's so good to be together. Yeah, so damn good. If you want to be together, it's so good, it's so good, yeah. What the hell's wrong with my telescope now? Yeah, what's wrong with this thing?
The lost Lone Ranger, can I break this spell? Do one thing right, do I make you two things wrong? If I want that fine line, I will always take the fall. If I just do left, watch it from the right. I sleep all day long, then I'm dreaming through the night.
I wonder what it was that made me want you. She couldn't understand what made me hard.
She's climbing in out my open window. I'm laying here alone and cold and drained. Yeah. So take another breath and come up for your oxygen. And now you wanna kiss the flesh and blood of every man, every man. And when the room is full and the wolves will hell, just swam across the
disgusting stuff. Disgusting stuff. She looks upon a world that's dark and tangled. I never saw her turn her head in shame. She's standing out the open window. I'm lying here alone, cold and gray. So take another breath and come up for your oxygen. Hey, you know you wanna kiss the flesh and blood of every man, every man. Well, we all took turns and swallowed the world. I never realized they said we lost man. And she said, I want more. Give me more disgusting stuff. A little bit of disgusting stuff. Disgusting stuff. Oh, you're making me well, we all took turns and swallowed the world. I never realized this up with us, man. She said, I want more. Give me more disgusting stuff. A little bit of disgusting stuff. Give me more disgusting stuff. Yeah, a little bit of disgusting stuff.
Hi everyone, Dan here, and I just wanted to put a little snippet about AstroWorld and what we do because I want to start getting the word out because I think it's becoming more and more of a giant community, and I want to get the word out to some other people. So what we do at AstroWorld is we hold astrophotography chats on Wednesdays at 9 p.m. and Fridays at 8 p.m. Eastern Time. And we just talk astrophotography. Wednesday's more of a techie kind of advanced intermediate, and Fridays is more of a newbie kind of thing. So if you want to check us out, and if you want to, hang out with some semi-decent people that like to go off the rails a little bit and have fun while they're doing it, come check us out at astroworldweb.com, and you can check out the schedule, and you can sign up for all the free giveaways that we do. We just gave away an Eagle 4 Pro, an Optilong filter kit, Charles Brackenstein's books, and a whole bunch of other stuff. So come to astroworldweb.com, hang out with us, have a good time, and as always, remember to keep imaging, keep educating, and clear skies. And I'll see you soon. Bye-bye. All right. How's it going, everybody? It's Friday night. It's the weekend already. I can't believe it. And we're here tonight with Pavel. Is it Cagas? How do you pronounce your last name, Pavel?
Yeah, in Czech it's Sagas, but
Sagas.
any pronunciation is okay. Yeah.
Well, Pavel is joining us all the way from Central Europe, so it's really late for him. It's like, what is it, 1 a.m. over there now, something like that, right?
Yeah, even we have summertime, so it's 2 a.m.
It's 2 a.m. Oh my goodness. Well, thank you so much for coming and hanging out with us and talk about Moravian, because I'm super excited about it. I want to learn as much as I can about it, because Pete has been talking and showing us what do you got, the C5 in your backyard there?
No, I got a C4 for a
C4.
CDK17 that I'm putting together. Yeah.
So yeah, so he's been showing us, and we've all been drooling about your press picture with the big C5 with the big sensor on it.
That's insane.
Yeah, that's incredible. But before we do get started, again, we do have to say thank you to our sponsors and all of our guests and our member sponsors. So let's get the formalities out of the way here. And what we'll do is, and we'll just get, let's see, we knocked off Pavel a little bit, so give me a second. Layers and Jesse and there's Pavel. There we go. And all right, so the guests. All right, so thank you to our sponsors again. We do sponsors all the time, and they give us lots of stuff to give away, like money and gifts and all that. Free classes. It's really a lot of people have been very generous over the past couple of years. So the first one is Woodland Hills Camera and Telescopes. They give us gift certificates to give away. We give away one every month, and not this Friday. Next Friday we'll be giving out another one. So thank you to Woodland Hills Camera and Telescopes, followed by Primaluce Camera Concepts and Optolong Filters. We have an L Extreme that we still have to give away, and we also have we got to figure out what we're doing with Primaluce. I got to talk to Tom and find out what we're doing this year, but probably won't be as good as last year, but we'll see. So thank you to all of them at the Red Giant level. Followed by our friends over at Masters of Pixinsight and IP4AP. These guys, Warren, Ron, and Pete, thank you so much to all of them. They give us, and we're giving away a Masters of Pixinsight workshop tonight to get ready for their next workshop. I believe it's this Tuesday coming up. So if you win, great. If not, go by their next workshop. It's really nice to have 2 hours with some of the best in processing. So thank you to them. We're still doing member sponsors, everybody. And if anybody wants to join us on Patreon, join us on Patreon, support the channel. We have a ton of people on there. And plus there is some Patreon only content on there that will be getting bigger as we move on. But you got to be in it to win it. So thank you to Sean and Bob at our Off the Rails level Quasar members. We got 3 Quasar members, John, Hassan, and Chris. Black Hole members, and yes, I know, Charity, you're still waiting on your shirt. It's coming. I finally nailed something down. George, Mike, Dave, Dan, and Tom, followed by our Red Giant members. Main secret, we have about 57 members right now, and these are just from Patreon and YouTube. So thank you so much to everybody that supports the channel. Tonight, like we said before, we're gonna have Pavel here from Moravian Instruments to talk about his line of instrumentation, his cameras. And look at that big C5 right there. I think that's like the size of a credit card. But May 17th, which is this Wednesday, we're gonna have Warren Keller on for part 2 of his M51 workflow. So he's going to be coming on and doing the finishing up on M51 that he was doing last month. So it's going to be fun to have him back on. June 2023. Still haven't pulled the date out yet, but Helena will be on after she graduates high school. So Helena Cochran from Helena's Astrophotography will be on to hang out with us for her premiere, our first time on with us on the channel. So that's going to be a lot of fun. And of course, if you want to join us on our Discord channel, please join us on our Discord channel. We have like 120 people on it. It's constantly filled with great content and great questions. So, lots of answers, lots of questions. So join us. We're also on YouTube. Subscribe to us on YouTube if you're watching us. Thank you so much. If you're not subscribed, please hit the subscribe button and hang out with us a little more. We're also on Twitch, Twitter, Instagram, and Facebook. So that being said, thank you so much, everybody, for dealing with my spiel here. And we are back to the regular scheduling program here, and we're here tonight with Pavel. So thank you, Pavel, for staying up really late and hanging out with us. Appreciate it so much. So why don't you just start it off by for some of the people that are new out there that don't know who you are? Why don't you give a little bit of an introduction of yourself and Moravian and what you do?
Yeah. Very, very simply, Moravian Instruments is a pure Czech company. It's owned by people who actually work in the company, by engineers and software engineers and hardware engineers and so on. We started development of astronomical cameras in the really long ago, around year 2000, with only CCD cameras were available, and our first customer was the Masaryk University in Brno, and later on we switched to CMOS, of course, and now we have a line of CMOS cameras from very small guiders, pointers, up to the very large cameras which are used literally all over the world. We have a camera on Concordia station in Antarctica, so we have cameras on all continents, and I believe the important point is that our cameras are made in Europe. The cameras are designed in Europe and also manufactured in Europe. A lot of things are done here locally in Czechia. And another important point is we are, of course, astronomers, amateur astronomers, because we do cameras for a living, but we love our cameras. We love to work with them. We use them in observation, astrophotography, scientific research, and so we never try to offer our customers anything which we do not personally test it and which we think it should be useful, and so well. I'm appropriate to. I have some slides which I can show, but it depends on the time which is available for the presentation.
Yeah.
Yeah.
I think we have the time. If you,
we got plenty of time. So we got.
Is yours.
Okay, so I will launch a presentation, and I can share the screen.
Yep.
It's sorry.
That's okay.
Yeah. I'm yeah.
There you go.
So
There you
hopefully
are,
you
yeah.
can see. Yeah.
Yep.
Okay. So Moravian Instruments, as I said, is a Czech company which started in around year 2000. Now we switched to CMOS sensor from obvious reasons because CCDs are no longer manufactured, and luckily the CMOS sensors are now I can say that CMOS sensors are much better than CCD, so it's not not a big deal. Our cameras are used for astrophotography by a lot of amateurs, and I believe the very best images are taken with our cameras. We have it's accessible on our website, and really world-class astrophotographers use our cameras. But our cameras are also used. I don't know if you can see it here, but I want to highlight this M1 nebula with perfectly shown pulsar, and also the shockwave which originated on a pulsar. So it's really interesting, which can be done with on a backyard. Yeah.
Wow.
But our cameras are also used in research. Here I have a few instances of research applications. For instance, on the greatest telescope in Czechia, the 2-meter class telescope from Zeiss Jena. That is in a focal plane. We have several cameras there used for photometry, for research. Here we have the telescope intended for gamma ray burst afterglow follow-up observation. We have cameras in Chile that's on ISO Observatory La. This is on ASA 1.5 meter class telescope, and so on and so on. The overview of our cameras. Our cameras can be divided according to type of sensor. I mean the electronic shutter on in the CMOS sensor. It's a global sensor cameras and a rolling global shutter sensor and rolling shutter sensor cameras. The sensor size is from really small sensors, approximately 4 by 5 millimeters, up to really big sensors, up to 53 by 40 millimeters. Here is a illustration showing the sizes of sensor. And this is my hand, and what I have in my hand is the greatest sensor we currently use. It's a 150 megapixel IMX411, which is used in C5 camera. So it's a really huge sensor. It's already soldered on some backplate, which is used in a camera. This slide shows how cameras compare to each other. The mechanical part, the C0 and C1 plus, C1 next line, those cameras are symmetrical. The C0, 1 and 1 plus can be used as autoguiders. They are equipped with autoguider port. C1X is bigger, and the symmetrical version is intended for possible use in primary focus of telescopes. The asymmetrical version are on the bottom line, C2, 3, 4, and 5. The asymmetrical version offers the body of the camera is bigger, so the asymmetrical version offers better cooling, more they can achieve lower temperature of the sensor, but they are also equipped with mechanical shutter. So if you want to take dark frame or bias frame, you just instruct using just software, take dark frame and shutter closes, and you can take a dark frame or bias frame. So it's not necessary to run to telescope cover rate and so on.
Wow, nice.
Here is a chart of conversion of quantum efficiency of sensor sensitivity, and it's obvious that the modern CMOS sensor approach the very best class of E2V sensor, which I mean the CCD sensor, which are on Hubble Space Telescope and or Kepler telescope, or now on TESS. Those sensors offer up to 95% quantum efficiency, but the modern CMOS sensor offer also around 85–90% efficiency. So the sensitivity is really great. But for research application, it's very important to have linear response to light. So the researcher can rely on the fact that the highest level of counts in a sensor linearly corresponds to the amount of light. So the linearity of modern CMOS sensor is excellent. Yeah, I can say much better than was the case of CCDs. Only a few CCDs achieve such perfect linear response as modern CCDs, as modern CMOS. So this is also very positive news when we switch to CMOS. And this was a very short overview, and now a couple of new products which we introduced in the last year and this year. So first, we introduced new C2 camera with the IMX533 sensor, which is pretty popular. It's pretty small camera, small resolution, but the sensor is really great. It's really very, very good sensor. We have an upgraded version of C1X cameras with a possibility to launch exposures using hardware triggering, and another possibility is to use a GPS module for very precise timing of exposure times. This is not that important for astronomical photography, but for applications like astrometry or space debris monitoring, it's very important feature. Then we already have a C4 camera with a GSENSE sensor with backside illuminated version. That's similar to already well-known 4040 sensor from G-Pixel, but this version is backside illuminated with much higher quantum efficiency. Quantum efficiency is around 90–95%, which is definitely above the 65 or 70% of front side illuminated sensor. Otherwise, the sensor is the same. I mean, the resolution is the same. Pixel size is the same. Then we introduced C5 cameras, and we plan to introduce, in addition to asymmetrical version of C5, we plan to introduce a symmetrical version of C5, which is also, those cameras are developed to the request of our customer who want to use those cameras in primer focus of a relatively small telescope, and the asymmetrical version is not that suitable for this purpose. So the C2 9000 with IMX533 sensor is a typical C2, but it's the first C2 version with a rolling shutter sensor. All other C2 cameras have global shutter sensors, so this is kind of exception in the C2 line. The sensor, as I said, is very good. It has literally zero amplifier glow. So the field is uniform. The read noise is very low. And in fact, the sensor belongs to the same family like sensors in C3 and C5. Only difference is that the digitization is not 16-bit, but only 14-bit. And the sensor is quite small. It's only 11 by 11 millimeters, which could be pretty useful when we have telescope, which is not that great to cover a large field of view. So even the moderate telescope can cover this sensor with a pretty good image. This is how the C2. This is how it looks like. Now here it's shown with a Canon EOS bayonet adapter for lens, but we also offer other adapters, of course. Next version, new product is a version of C1X camera with a GPS port hardware trigger. The GPS module is the same like on the C5 cameras, and we have two variants of GPS module. One variant is with internal antenna, and other variant is with the external antenna. The difference is obvious. Yeah, for GPS receiver with external antenna, you have to attach antenna, otherwise the receiver doesn't work. But the external antenna provides much better reception. That's simple. You can achieve fix to satellites much faster, and you can receive signal from more satellites with external antenna. This is how the C1X camera looks like with antenna. So on the left is the original version. On the right side, there's a version with a attached GPS module and external antenna.
Hey Pavel.
Yeah.
How much does that weigh, the C1? Do you know?
Sorry.
How much does it weigh?
Yeah, the weight. Oh, yeah. I have to check our website. It's about 1 kilogram, about 2 pounds, 2 or 3 pounds.
Okay.
I believe I can tell exactly, because if I go to our website and go to the products, C1X, and there is a product page, and then in mechanical, cooling, power supply, mechanical specification. Oh, it's less. 0.85 kilograms. It's less than 2 pounds.
Yep.
Yeah, that's nice. Okay.
Okay. Here is a comparison of the original C1X, which offered the power supply, filter wheel connector, and USB connector, and the new version of includes also the trigger input. And this is the cover of GPS module port. So if the GPS module is not used, it's just covered with some black plastic. Otherwise, those cameras are identical and can be used same way. The SIP software, the new version of SIP software contains a new tab in imager control. It's a GPS tab, and the GPS tab shows the information whether the receiver is present and what the geographical location and what's the exact time. The main purpose of GPS is timing of exposures. That means if the GPS is present and if it's locked on satellites, then the precision of exposure timing is better than microsecond, which is very good. Yeah. So new version of C4 with backside illuminated sensor. Here's conversion of the CCD KAF 16803. That's the famous sensor used in G4 cameras. In the middle is quantum efficiency of the front side illuminated G-Sense 4040 sensor, and then on the right side is a quantum efficiency of the backside illuminated G-Sense 4040 sensor. Especially in ultraviolet light, the quantum efficiency is excellent, and for applications for ultraviolet detection, it's a really great sensor. Otherwise, those cameras are the same. There are a few differences, like the backside illuminated sensor does not support hardware binning, so binning must be done by software, but it's not that important. It's for usage in astronomy. It's totally unimportant. And the the best cameras we ever developed is the C5. The C5 cameras are designed for the 100 megapixel and 150 megapixel Sony sensors, and the front cross section of the camera is the same like C3 and C4, but the design of cooling is different. It's much more powerful because the sensor is much bigger, and it needs much higher cooling because of thermal losses. That also means that the power plug is different. It's not the simple power jack. It's a new four-pin connector, which is capable to handle higher current than the standard sensor plug. The C5 also can be equipped with a GPS module. This slide shows the camera without GPS module, with a GPS module with internal antenna. There's the orange covers the entire GPS module. And on the bottom, there is a camera with an external antenna. The GPS module is exactly the same like the one used on C1X cameras. So this is the same GPS module. I already described the mechanic is similar. Also, C5 cameras are equipped with mechanical shutter, so it's possible to take darks even if you have some open tube, or you cannot just simply cover the telescope.
Yep.
And here is the C5 on my observatory. In fact, I am now sitting a couple of meters under the dome with this is my telescope with this camera, because I said it in the introduction. We use our products that's to be sure that they are really working well.
And what scope is that you have it on? What kind of telescope? What telescope do you have it on?
It's a custom-made 12-inch Newton with a paracore big 3-inch corrector, but I just plan to upgrade to 4-inch corrector from ASA, from Astro System Austria, to cover the entire sensor of large C5 camera. So
wow.
In fact, this telescope will be moved away from the observatory soon, and will be replaced with a new one, which is also 12-inch. The diameter is the same, but the secondary mirror is bigger because the current one uses 110 millimeter secondary mirror, and the new one uses 130 millimeter secondary mirror for much bigger field of view.
Yeah.
And this is this image. It's available also on our website. This is the first light of C5 camera on ASA 40 centimeter telescope with a very fast telescope and extremely large field of view. So the original image is 150 megapixel image, and it's really beautiful. It's a very short.
150 meg, right?
Yeah, 150 megapixels. Yeah.
I just want, you just got a question on that. I just wanted to reiterate what you said. So.
Yeah. And we, as I said, we also we plan to introduce the symmetrical version of C5 cameras. I'm sorry, I have only renders. The mechanical part is not in black anodizing available yet, so
That's okay.
I had to do a computer rendering. But this is a comparison of the symmetrical and asymmetrical version of C5 cameras. The symmetrical version lacks the mechanical shutter. It's not present because there is no way how to put a mechanical shutter in this body. But,
it's too big.
Yeah, it's pretty big. Yeah, yeah. But the sensor is big too. Yeah.
Yeah. That sensor is huge, man. And you know what? I used to have a mechanical shutter on my S-Big cameras that I used to use, and
yeah,
that's the one thing I miss these days is that mechanical shutter, and you can just sit there and do your routine, and take darks the same night, and just do whatever you got to do, and that's one of the benefits of having that mechanical shutter there. It's really. Once you have it, you never want it to go away. But unfortunately, in the age of the CMOS cameras that have come out and the rolling shutter, it's changed a little bit.
Yeah.
So
yeah, it's true that mechanical shutter is not used to actually time exposures with CMOS cameras. For CCD, some CCD offered electronic shutter, but the full-frame CCD, like very popular 8300 version, KAF 8300.
That's what I had.
So
yep.
Yeah. It was a great sensor.
Yeah.
But those sensors need to be covered by shutter when reading. Otherwise, the star will leave trails as the image was shifted through the sensor. So mechanical shutter was a necessity with those cameras, and it took time to open and close the shutter. In the case of CMOS, if you start a series of light exposures, shutter opens and it remains open until the next exposure is dark or biased. Then shutter closes. And if you stop exposing, then the camera firmware waits a couple of seconds, 8-10 seconds, and then closes the shutter if no exposure is asked. If the next exposure is light, then shutter opens. If it's dark, it is kept closed. So the shutter works differently than in the case of CCD cameras, but for the case you want to take dark, it's very useful. And also to cover the sensor if you accidentally point telescope to sun during day or so. So it's always good to have the sensor covered.
Yeah, absolutely. You don't want to fry that thing. But I think when you switch out of the presentation, I think Pete has something to show you real quick.
Sorry, I'm not sure.
No, you just if are you done? Is that presentation finished? Because you just got to log out of the presentation.
Yeah. So I believe I turned off the sharing.
There you go. There it is.
Yeah. Okay. I just click stop sharing and I have to click the
That's okay. That happens every time we have a guest because it's a completely different type of platform. Nobody's used to this platform, so.
My gosh, Pete,
Yeah.
what is
there
that?
It is.
Pavel,
looks familiar
this
to
is-
me.
This is
It's better.
that's going on a CDK, a plane wave CDK 17, and it's going to be part of an article that will be published in September or October in the Sky and Telescope magazine. So we're going to make reference to you on this particular C4 camera.
Yeah.
It's just it's a beast, but boy, I tell you what, I can't wait to see what the images look like on this camera.
It's going to be amazing.
It's true that C4 is a bit tricky. Not C4. I mean the GSON sensor is a bit tricky to calibrate because the sensor in fact, sensor provides two images at once, the high gain and low gain image. And the high gain and low gain image is combined into 16-bit image, which is it is pretty good, but it introduced some problems when calibrating because in fact you have two images, two frames, and the pixel of the resulting frame originates from the high gain or from the low gain frame, and it's also necessary to calibrate it correctly. So I believe we describe it in the user manual of C4 camera. So there is a description of the procedure which has to be followed to properly calibrate the image.
So Pavel, if I heard this correctly in your presentation, the new version of the C4 camera, which is the BSI camera, you're only going to be able to do 2x2 software binning, not 2x2 hardware binning. Is that correct?
Exactly, because the sensor itself does not support hardware binning. But honestly, the binning feature of the GSON sensor is, I would recommend to use software binning, even if the hardware of the front side illuminated sensor offers hardware binning. I would recommend to use software binning because results are better. It's less noisy and simply better. Yeah.
So once again, on the new C4 BSI, we can do 2x2, 3x3, and 4x4 binning software, correct?
Yeah, that's correct. Yeah. And also asymmetrical binning. That means you can bind 1x4, by 3, or whatever combination from 1 to 4 on both axes. Yeah.
Oh, that's interesting.
I like that. That is interesting.
So,
yeah, in fact, yeah.
No, I was just wondering. You got so many great products. I mean, I've always heard of Moravian. I've been doing, not as long as Pete has. Pete's been doing this since I don't know, Hubble when he was there. So I mean, he's just but I've been doing imaging since I guess the early 90s to mid 90s to now. And Eric's been doing it quite a while. I know Pete's been doing it quite a while. We've all heard of Moravian cameras. It's like one of those things that you look at it and it's like the golden, chalice.
Yeah, it is. That's like for my retirement fund. That's like the holy grail. Just the size of these beasts. It's incredible. I mean, I understand that it's not. Maybe like the C4 isn't necessarily like for my Schmidt Cassegrain, although I would love a camera with those pixel sizes, these large, big, pixels, for a long focal length. I think they're fantastic. But yeah, Pete, you gotta hook me up. You gotta help me out getting like a CDK 12 or 17, dude. I gotta figure out, I think I got $50 around here somewhere I can convince Robin to let me borrow,
But
so,
I mean, that's a good point. Eric, that's a good point, because we talk about that on the show quite a bit on, how to match cameras up to image trains and to get to that nice little sweet spot between, 2/3 and 2 on the sampling, so on your arc seconds per pixel. So where, your largest, I believe, if I remember, the C5 right? It was a 9-micron pixel size, if I remember right. Correct?
I'm afraid that that's not the case. The 9-micron is a pixel size of C4 camera,
Oh,
not C5.
C4. I'm sorry.
Yeah, it's a C4, the G-Sense G-Sense sensor, but the Sony sensor, those sensor using C3 and C1X, C3, C5. The pixel size is 3.76 microns,
Yeah.
so it's slightly less than 4 microns per pixel. But it's a as I said, those Sony sensors are really miracles. Simply think about this: when you use a G-Sense with 9-micron pixel, you have about approximately 55,000 electrons per pixel.
Wow.
And if you have the much smaller Sony pixel, the 3.76 microns, you have 50,000 electrons. So the charge density is much higher of the Sony sensor. So you can use binning, and if you bin those pixels, you have much higher dynamic range, which is great. This is really. When I first put our first prototype with the Sony IMX455 sensor on my table, and I did a shot noise series of images to characterize pixel, to measure the well capacity and so on. I hardly could believe what were the results, because really the one pixel contains up to 50,000 electrons. That's wonderful.
Yeah.
In fact, that's a much higher charge density on the sensor area than is the CC in the case of CCD used on Hubble or whatever. So it's not necessary to be afraid of small pixel if they can hold enough electrons. The dynamic range is even better than in the case of large. You just bin it.
Yeah, you just bin it.
Quick question to ask you, Pavel. On the C5, the 150, when we're looking at a 65 by 65 millimeter square filter, why is it that we only have access to a 5 filter wheel carousel instead of a 7 filter wheel carousel? Is there a reason why we cannot look at? I know it's going to be huge, but people they want to look at LRGB and HJ03S2, so they want to definitely look at 7.
Yeah, we are aware of this, and we plan to introduce a new filter wheel. Our filter wheels are now called external, E filter wheels, and new line will be standalone filter wheels. That means the current line of external, because C2, C3 cameras can have filter wheel inside the body. Yeah, they can have internal filter wheel, or they can have external filter wheel. And the idea was that if there is no internal filter wheel inside the camera, the electronics stays idle. So it's possible to just plug the external filter wheel into the electronics. So our filter wheels are really how to explain it? They do not contain any electronics, nothing. Everything is in camera, and camera controls the filter wheel. This is the external filter wheel, and the standalone filter wheel. The shell of the filter wheel that contains the power plug and USB plug. So that's like filter wheel from other manufacturers. I mean, with a independent plug to the computer control and everything. And the standalone filter wheel will be designed in a 2-wheel. There will be 2 wheel with 5 positions. So in fact, you have to keep one position clear, because if you have two wheel, one over another, one position must be clear, and you have 4 position in
You'll
one
have
filter
9.
wheel or in other. So you have 8 plus clear positions, but the filter wheel is huge. Yeah, it's really massive.
Yeah. It's kind of like the FLI dual filter wheel carousel. So on the C5, on the C5 camera, on the telescope interface, telescope side interface, what's that thread size?
Sorry, I did not understand.
On the C5 camera,
Yeah.
the adapter that's on the telescope side of the camera, what is that thread size?
Yeah, thread size is 85 millimeters with a 1 millimeter pitch. So it's M85.
That's massive.
Yeah. If you look at the C5, there are also threaded holes, so you can use either the M85 thread or threaded holes around the adapter. So there are 2 ways how to attach camera to the telescope. But the primary, it's
So we have the choice of we have the choice of either bolted or threaded, is what you're saying then. Being bolted without without the adapter, and then threaded being with the adapter.
No. The adapter contains threaded holes.
Yeah, it's got holes in that. It fits.
M85 thread.
But my point is this: is if we took that adapter off, we got the bolts, right? So we could use precise parts to actually.
Yeah. That's another. That's something different. Yeah, you can always take the adapter off, and you have threaded holes. But in the case of C5, well, I can show you what I mean.
And just while you're looking that up, and so Norm, no, I would not suggest putting a C5 on your Red Cat. Don't do it. You could buy 6 Red Cats with the cost of that. You more than that with the C5. So
yeah, I can share the screen. Yeah, here it is. So that's C5 in my hand, but it's only the 100 megapixel version, and you can see this is the M85 thread, and those 8 holes can be also used to attach the camera. So this is in the front side of the camera. It's maybe it could be seen here too.
Yep.
So just to be sure, once again on that, Pavel, if I did take off that M85 adapter, then I would get a precise parts that would be bolted, or is there female threads on the telescope side of that camera with the adapter removed?
No. With the adapter removed, well, our cameras are designed with a tiltable adapter, so the adapter can be very slightly adjusted to put the sensor perpendicular to the optical axis. The adjustment is done by the pushing and pulling screws. That's normal adjustment. And
so
if you
are those those small push-pull screws? Those are the small grub screws, right? Those 3 smaller.
Yep.
Okay.
Yeah, it looks like and one thing I gotta say, there are some other camera makers out there that make the lovely tilt adapter on it. That once you put a filter wheel on it, you can't touch it at all, and it looks like that it's nice to see that people are starting to come out with tilt plates that are actually functional when you're adding accessories on, because once you add accessories on some of these other cameras, you can't even touch them.
Yeah, I like the forward thinking.
See, there you go.
Yeah.
That's the way you do it. Just like that.
Yes.
You take the tilt plate off, you put the filter wheel on, then you put the tilt plate back on the
Then
filter
you
wheel.
put it back on.
Yeah. Yeah, exactly. So the tiltable adapter is always on, but it's still possible to I'm not sure if I can explain it clearly. The camera body, there are 6 threaded holes on the camera body. Those 6 holes can be used to attach either external filter wheel,
right,
or the base on which the adapter, tiltable adapter are attached. So the tiltable adapter is either directly on external filter wheel or on some base which is attached instead of filter wheel on a camera. If you remove the base, you can always use those 6 those 6 threaded holes to attach anything you want to the camera.
Nice.
But this is the how the tiltable adapter looks like when it's removed from the camera.
Got it.
And I believe when we check the C5 camera product page, then in the mechanical specification, yeah, here it is. Yeah, this image shows the six holes, threaded holes on the camera body. Those holes are used to attach the adapter or the filter wheel. Yeah.
Nice. Well, that's great. I mean, I love these cameras, and from what Pete has been telling me, because Pete's the one of the group that has the most experience, touching and feeling the build quality of the Moravian. He doesn't say, he doesn't say anything bad about it. It just says everything how great the build quality is of your cameras. So that's kudos to you over there at Moravian, because it means a lot. And it's when you're looking for a camera, it's kind of like what were we talking about, Pete? You're getting a Porsche and you're getting really bad tires and putting it on a Porsche, So
Well, yeah, basically what it is that if you're spending a high dollar volume on a nice high precision mount, a very nice scope, why then do we want to go cheap on the optical train? It doesn't make sense, because it's like getting cheap tires on a Porsche or Ferrari. My goodness gracious, if you're going to go all the way through, just go all the way through, right from beginning to the end,
Yeah.
Because you're absolutely right. And I love the build quality of these Moravian cameras. And Pavel, I've been emailing you over the last couple of years. You've got the right pixel size for the image scale that's needed for these high CDK, 14, 17s, and 20 inch scopes. It's just amazing that you're the only one really right now that has that capability. That's definitely a prosumer camera that is really within the price range. And that's good too, because it is a very, very comparable price.
Yeah. And you hit on it right there, Pete, when you gave that name, the prosumer. This is what I think this is, Moravian, and Plane Wave, the CDKs. When we talk about and we've had questions about what type of scope would you select, or would this type of camera, be well matched with. It is those larger, probably the more well-known prosumer CDKs, the 14s, the 17s, the 21s, that this would be a match for. Versus, and I'll be honest with you, like for me, the get started backyard observer, this is not the right match, because we want to match the right equipment together. That's that's what we always talk about, is matching the right pieces of equipment together because what do you always say? Buy once, cry once, right? So
Yep.
Moravian with a CDK or maybe an or of the like, and you've got a great, you know, observatory grade mount like the plane waves, you know, the L 350s, these types of systems, that this is the match. You know, when people are asking, what does this work for? Here, I'm telling you right now, this is the match. And
Okay.
if you don't ask me, Pete can tell you right there, this is the match. This is the setup.
Just don't forget the C1s, the C2s, and the C3s, because you know
That is very true.
Those are the 533s, and those are the ones that are out there. Those cameras are right in that price range of that.
Yes.
You know, that ZWO high end 6200 full frame cameras. They're in the same price range. So don't, you know, for those of you that are out there and seeing, okay, yeah, you know, we all see the C5. It's the biggest one on the lot, right? We see it, you know, and that's what you know, and it's a 10,000 plus camera. So you know, don't forget the other part of the lines here, because you know, if you want a superior build with great camera and great support, you know, that's what you're paying for, and you're right in that price range. You're right in that area with those the C1Xs. I mean, you're right there.
And to go with that too is what Pavel, what we initially talked about is that on the Moravian website, on the download, and Pavel, chime in anytime, please. They have what they call their scientific imaging and processing software. It's a free software. It's called SIPS. And believe me, if you like Nina, you're going to absolutely enjoy SIPS. And from what Pavel is saying, Pavel, I'm not going to steal your thunder. I'll let you talk about what might be coming up here in the summertime with the next version of SIPS.
Yeah.
Trade secrets. Trade secrets.
No. Honestly, I'm a little bit nervous when I have to introduce SIPS version 4, simply because you know, in the history of computing, and I am in computing from the very beginning, from the 8-bit computers. Every new upgrade of user interface was acknowledged with a positive feedback from users, like you introduce menu, then you have toolbar. And the first upgrade of user interface, which was received with a mixed feelings, was ribbons. And we reworked SIPS version 4 to use kind of ribbons, not ribbons like Microsoft in Office, but the user interface is similar. I believe it's much more configurable, but this is only the front end of the software. But the SIPS version 4 has two most important new features. The one feature is it is scriptable. That means there is a program tool, and you can write programs within the environment of SIPS. And our goal is to offer full functionality of the SIPS to the programmer. So you can script the entire session, including searching for opening the dome, synchronizing telescope, and everything. And another important feature is the ability to access SIPS through a web browser. So you can run the SIPS on a computer close to the telescope, or possibly mounted on a telescope, and then to use any web browser to access SIPS and to control observation, to take images, download images, and control the mount and everything. I have the development version of SIPS here, so I could possibly show you how the version 4 looks like. But only a brief introduction of SIPs would probably need a long time. So I'm not sure if it's appropriate to do it just now.
Up to you.
But what I want to emphasize is that the SIPs, really, it means scientific image processing system. When we first started to develop SIPs, it began that we developed the first CCD-based camera. It used the KAF 0400 sensor, the very popular, used also in ST7, SBIC, and so on. And we need to check, to judge what the camera actually returns the image. So we have to write a simple software which is capable to read the camera and show the image. This is how it began. It was named SIMS, like Simple Image Manipulation System. But then we were noticed that there already exists a program called SIMS. It's a game, computer game. So we changed the name.
Yeah.
From
Electronic Arts might have been a little bit upset with you if you would have kept it at SIMS.
Yeah. So so SIPs, the version 1 was SIMS, and the version 2 was renamed to SIPs. But I want to emphasize that there is very powerful tool for photometry. Maybe the SIPs is designed for acquiring, controlling camera and telescopes and everything, focusers, filter wheels, but also to process images. But we do not intend to compete with software designed to process astro images, astrophotographs, I mean. But the strong feature, the SIPs is strong in research processing, in photometry. So for people observing variable stars or exoplanet transits and so on. So for this kind of image processing, SIPs includes very powerful tools to do the scientific image reduction and photometry analysis. Yeah.
Nice. Well, we had one comment. I think Mark was mentioning. Yeah, we may like to have you back on, to show us SIPs at a, we can dedicate a bit more time to SIPs so we can actually see that, versus at another date. So if you wouldn't mind coming back at a later date, and showing us SIPs, I think that would be really advantageous for our viewer membership here, because we've got some interest here, it seems.
Yeah, if there is interest, I would really love to show you SIPs, because I'm a principal developer and also user.
Okay.
And that I really would welcome the possibility to show what the software does and what can do for observer.
Yeah, that would be fantastic.
Yeah.
It is a good software. I'm very, very impressed with it. And I'd recommend that. I mean, if people are used to Nina, then definitely SIPs is a very good program that you'll definitely be able to cross-reference very, very quickly.
Yeah, I know about Nina. I've seen this software a couple of times, but I have no experience with it because of course, if I use my telescope, I control it with SIPs, of course, including dome and focuser and everything. So. But of course, I'm really glad to hear that people like SIPs, because the feedback is often that SIPs is very complex. It's too complex. It's too. People say, yeah, it's too complicated. But on the other side, SIPS is evolved based on the user request. So everything in SIPS was requested by some user, and we only take care not to put it like sparrow nests, but to organize it, to make it symmetrical and keep the overall functionality, some regular symmetrical and so on. So
makes sense.
well, one SIPS version 2 and version 3, you use image sets. That's the way how to organize multiple images. If you calibrate images, you just have to put it in sets. And I was notified that the word set can have some negative sound to some people. So in version 4, functionality is exactly the same, but instead of image set, there is an image list. So this is the one change. Everything is the same exactly, but it's named list. In fact, it's image list. Yeah, maybe it's more.
I learned something new today. I didn't think the word set was an issue. So
yeah, maybe it has something to do with learning math in elementary school, where the sets are. But maybe it's local.
That was too long ago for me. I don't remember.
Well, we have a guest on that I'd like to introduce everybody to. His name is Wes Harrington. Wes has a CDK-20 that he's actually building a remote observatory for.
Is he in the chat?
He's in the chat right now.
Oh, okay.
And he's been listening. So do you remember that Rotarian that the gentleman had from Belgium? Remember that little 4-point Rotarian camera?
Yep.
Well, Wes had bought that. And then what we're doing, Pavel, is we're getting a C4 camera to go with it. And it's going to be on his optical train. And it's going to be a very, very unique optical train to design it. I tell you what, Wes, if you're listening, we're going to have to get some images of this, because Pavel, when you see this, I think you're going to be impressed with what we're going to do on this thing, because it really is a very, very unique optical train. So what we've got is we've got the back of the CDK-20. We've got the integrated rotating focuser, the IRF 90. And then we've got a couple of, we've got an Optec Sagitta. And then we've got a SPIG AFW filter wheel. It's a 10-port dual filter wheel assembly. Then we got the Rotarian, and then we got the C4 camera. So we're going to put this whole optical train together. It's just going to be one of the most unique optical trains put together. So
I want to see pictures of that.
I want to see pictures of that.
And I want to see the Rotarian move too. I want to see that thing go.
Well, Wes, if you're on, please, if you've got any
questions. He's on. He's in the chat. He said he's here.
He's in the chat.
Oh, good, good. But yeah, it's going to be quite the setup, because that Rotarian is going to be real interesting.
Yeah.
And we saw it there at NEAF. It was kind of an interesting setup. So it's going to be quite something different.
Yeah.
It's definitely gonna be fun to do.
I hope it works.
He's like this. Please let it work. No. And listen, Wes, you're in good hands with Pete. It's like he's like Allstate. So.
Absolutely.
It was good to meet. I met Wes for a quick second at NEAF. So nice to see you again, Wes.
Exactly.
Pavel, you're going to have to definitely come over for either the next NEAF or maybe the next AIC, which is maybe going to be in San Jose next year. I don't know what it is, but you've got to definitely come over and actually have your cameras, because they are really something that you need to kind of come over and present to the American public.
Yeah, absolutely. You are right. We thought about being at NEAF this year, but I believe it was in April.
Yeah.
Or
yes.
Yeah, it was in April, and a lot of things has to be done, and it was too late to come. But if I start planning soon enough, then yeah, it could be really I believe it's a good idea to be there. It's not easy to move some dummy cameras or everything over the ocean, but
Yeah.
but it could be managed some different
Oh yeah,
way.
you could
But
you know, you could ship them right on over, and they'll put it in the warehouse. So I mean, you know, a lot of people like even the Primaluce guys, and they ship all their stuff over. You know, many people ship stuff over, and they have a warehousing thing where under security and everything. So that's
Yeah.
it's never been a problem so far. We actually had our own table. AstroWorld had our own table at NEAF, and had a really good turnout. It was really wonderful seeing all the fans and everything come and hang out and stuff like that. But this year in 2024, I've made a decision. We're gonna have two tables, and we're gonna have two tables side by side. And I don't know if you know this, Pavel, but I've opened up a Astro retail shop online. We have Skywatcher, Primaluce, Player One cameras, Televue. I mean, we have a whole bunch of stuff on there, and it's a lot of fun. So we just opened up the store at NEAF, I think, really. But
much.
it's a lot of fun. We did a lot of giveaways and stuff like that. And I still got. We're gonna do this on Wednesday night. I still have this guy. There you go. I still have it. This is the AstroWorld. What happened?
Oh, it's the closet of death is going down. It's going down.
Closet of death is going to, and the closet of death is dying, and there you go. So this is where like precise parts adapters that you don't use anymore and everything, it ends up in something like this in somebody's closet with shelves like I have right over here, where things just go to die. So so you know, or get sold on cloudy nights, one or the other. So but that's going to be given away. We're going to give this away Wednesday, because nobody won it at NEAF. I tried to give it away at NEAF. Nobody won it. Whoever had the ticket never showed up.
Pavel, just a quick question to ask you, and this is going to be for Wes as well. If we wanted to remove the M68 adapter from the C4 camera, what is those four bolt holes? What are those? Are those M4, M3?
yeah, those are M3, 52 millimeters apart. So this is the this is the standard we use for a long time. The C2 and C3 cameras have 4 M3 holes, 44 millimeters apart, and C4 camera has 4 M3 holes, 52 millimeters apart. And then we have to change it for C5. We use 6 bolts instead of 4 because of the heavier body.
The weight, sure.
Yep,
so there are 6 M3 holes, and not in the corners of a square, but around the circle. Yeah.
Nice.
Yeah.
Man. Yeah, Eric's got his puppy behind him.
Oh yeah, Titan, he's right here.
Yeah. So what's next for Moravian? Is there anything on the horizon for Moravian that you could that you could say? I know you got plenty of stuff in the works, but you know, I don't want to just wondering what's up next for you.
I already mentioned the standalone filter wheels. That means filter wheels which could be used also with other cameras, not only with Moravian cameras, but also with other cameras, because those filter wheels will have a standalone power line and USB line to control, and possibly serial line or Ethernet line. The new controller handles or Ethernet, serial line, and USB line as well. Then we plan to introduce update of the C2, C3, C4 lines with a possibility to connect a GPS receiver too. So also other lines will be able to connect to GPS receiver. For imaging, there's no use for GPS receiver because you just have to accumulate enough data. For instance, for occultation, for people who observe the transit of asteroids in front of some star, or their precise timing is crucial. So the GPS receiver is a big plus. And a lot of cameras are also used not to observe stars or planets, but to observe satellites and space debris and this kind of stuff. And those cameras are they also need to calculate the astrometric precise position of satellites, and they need to know very precise time. So that's why the GPS is present. And the plus side is that if you need a geographical location, then the GPS naturally provides coordinates.
Sure.
Another maybe distant future is camera with a G-Sense 6060 sensor. This is a big brother of 4040 sensor. It's 6 by 6 centimeters. I believe the pixel size is 10 microns.
Wow.
So it's really a huge piece of silicon. That's for the big telescopes. For the Austrian ASA, they manufacture up to 2.5 meter telescope, and for this size of telescope, the large sensor with large pixels is necessary. So
now, let's see. I did have a quick question here. I'm looking on your website, and I do see the C1X 2600, which is using the IMX 571. Are you planning on, and I apologize if you mentioned this before, but are you planning on utilizing the 533 sensor at all?
I believe I already mentioned it. It's built in the new C2 9000 camera. So this is not in C3 or C1X. It is in a C2 body for now. Maybe we introduce it also in a C1X body. That means the symmetrical body, not the asymmetrical like C2. But currently the camera is already available, and it's in the hands of testers. We are getting feedback from the camera, and it should be delivered within a week or two from now.
Nice.
Nice.
Awesome. Well, we got a really good question from Captain Rescue too. Now, just recently that we've seen the, I guess not a resurgence, but I guess another camera has come out with a onboard guide chip as right above. I mean, the S-Big used to have the onboard guiding cameras. They have a guiding chip in the camera body. What are your thoughts on this type of design, and does Moravian have any plans on doing something like that?
If I am not mistaken, I believe there is a patent for the guiding chip inside the camera, but I personally, I'm not sure if it's a good idea. The main reason is filter, because
thank you.
filter in front of imaging sensor, you filter also the light to the guided chip, and that's the very, very big problem. Maybe especially if it's narrow band filter, yeah, or
Yes.
some very narrow band, or research application often use ultraviolet filter, and you have really problems to see Vega through this filter. It's really dark filter. And so the using of such filter, in fact, it eliminates possibility of guiding.
Yeah.
So
I mean,
and
Yes.
no, go ahead.
And
go ahead.
what's more, if you use off-axis guider, you have exactly the same functionality, like if you put another sensor inside the camera. But you have a choice of the guiding camera. You can choose camera with small sensor or bigger sensor or whatever. And if you cannot find the star on off-axis guided mirror, then you can remove the guided camera and put it on standalone telescope. Yeah. So the flexibility is another plus of keeping the guider and imaging camera separate.
Yeah, I mean, we've been going back and forth on this on the show since I guess probably since like March, and you know, and I've been trying to get an answer from I mean, I've seen them before. I saw S-Big had one a long time ago, and I know that you know ZWO has just come out with one recently. And you know, I try and get an answer for the question. Well, what about the filter problem? Well, I want to put. I'm from Long Island. I'm in Bortle 8 or worse. I said I'm pretty much stuck to narrowband. So what? How does that work like that? And I didn't get an answer. So I'm waiting to hear answers on that on the the recommended way to do imaging with that, but we'll see as more information comes out. So,
well, the Fraction Limited has what they call their star chaser, and this is one of the issues that Wes and I have been going through. Is that we needed to go with their particular AFW filter wheel, which is their 2 carousel filter wheel. And they've got their star chaser, and basically their star chaser is kind of like what you said, Dan. It's kind of their they don't call it a pick-off prism, but it's a mirror.
Pick-off, okay, mirror, okay.
Like a mirror, but it's 15 millimeters wide, so it's kind of got a large it's got a large surface area, which is kind of nice. But they've got the camera already in as part of this star chaser. So it's not like you get a lipstick guide camera like say a ZWO 174 Mini. It's already got the guide camera in there, and then you can kind of rotate or you can move that camera up and down. It's got a pull-out maximum distance of 3 inches. So definitely, you know, when we look at OAG, you got to have distance A equals distance B to be able to get focus for your primary camera as well. So I'm not really kind of sold on it, but this is going to be interesting how we get this thing looking with what Wes wants to go with. But I think now that, Pavel, you've answered the question, we're really limited by back focus distance on his CDK20. But since we can take off that M68 adapter, we can definitely save up some spacing now, and that's going to actually help us out. So I'm really looking forward to this. So you've answered that question.
Yeah.
One other question that I have is looking at a lot of, you know, the cameras, especially in your situation, Pete, but I'm just looking, you know, that's quite a long focal length camera, and I should say scope. The guide cameras that you currently have to deal with the longer focal length telescopes, what would you recommend for the type of, you know, for the current guide cameras that Moravian has? What would you recommend a certain type of guide camera to pair with a long focal length telescope, say over 14,000 millimeter focal length or anything like that?
It's not really the guide camera, it's the pickoff prism. It's the size of the pickoff prism. You want to
It's
go
the
with
pickoff
a
prism,
large
okay.
pickoff prism because you got to have that real estate.
Yep.
And then when you go with like a 12.5 by 12.5 pickoff prism, you've got to get a guide camera sensor that has a lot of real estate. Case in point, it would be like the ZWO 174 Mini,
Yep.
or maybe the Lodestar
X2.
Lodestar Pro. Yeah, well, the X2 is discontinued.
Oh
so it's
yeah,
the
I'm
Pro
sorry, the
version.
Pro. You're right. Yes.
Yeah, but what I'm thinking is okay. So if you're talking about the prism and the pickup prism is like a 12 millimeter, does your off-axis guider, is that one? Because I was looking here at the website and I haven't had a chance to look at the off-axis guider yet. Is that a pickoff prism of about that 12 millimeter, that 12 by 12 size? Is it about that large, or is it larger? I'm just kind of curious to help with dealing with these, you know, that longer focal length in the situations that like some of us come across.
Yeah, the mirror is 10 millimeter wide in our off-axis guiders only. That means the greatest sensor which is useful on off-axis guider is the two-third form. That's
Okay.
maybe 8 millimeter diagonal or so.
Okay.
That means because there is not when we think about guided camera and long focal length, we do not we cannot choose the pixel size, because those sensors always have pixel size around 3 microns or so, the 3 and between 3 and 4 microns, and so if the focal length is really long, then you have to bin pixels even on a guider. And if you have a guiding camera on a standalone telescope, you can choose camera with a great big sensor and to make searching for some guiding star easier. But if you have a camera on off-axis guider, it was mentioned here, using a 12 megapixel guider is useless because the mirror will cover only a small fraction of the sensor. So in our line, the C1 5000 is the greatest camera which is useful on off-axis guider. Yeah, but SIPS offers, and it offers it for a very long time, and people are not aware of it. The SIPS offers automatic guiding too, so it can read camera and guide the mount, and it can guide the mount not only according to one selected star, but also based on the plate solution. So SIPS can find all stars within the field of view of guided camera and match it with all stars on a reference image and make the correction based on average of X and Y axis shift of all stars. So the guiding can be very precise, even if the focal length is not that long. So even if the standalone guided telescope with a shorter focal length, you can still have very precise guiding.
Nice.
And SIPS also have one more feature for users with mounts which can keep the star on a pinpoint star during one exposure. The SIPS have inter-image guiding feature, so you can just download image from main imaging camera and compare it with a reference image taken when you turn off the inter-image guiding, and very slightly shift the mount, and then start another image. This is useful again if you use for instance 10 minutes or 20 minutes long exposures for narrow band. There is no mount which can perfectly track for 20 minutes, I believe. But if you use say 2-minute exposure or something like this, then a lot of mounts can handle 2 minutes without pointing and without any negative effect on star quality. And SIPS then only corrects some long time image movement over the field of view caused by refraction or whatever. So this is also a capability of SIPS to do inter-image guiding without guided camera at all. But you have to have a good mount to
Hey,
That's
Pavel,
good
quick
to know.
question I
That's
have.
really good to know.
With the advent now of these wave strain harmonic drive mounts, and with SIPs, I know that you got the choice to use the ASCOM driver specific for these harmonic drive mounts. Are these going to be recognized within SIPs here with like version 4? Because everybody likes the portability aspect of these harmonic drive mounts.
I'm sorry, I'm not sure. Well, SIPS supports ASCOM drivers, of course. So if there is an ASCOM driver, if there is ASCOM drivers, just choose ASCOM. SIPS supports ASCOM standard. You can have ASCOM camera, ASCOM mount, ASCOM dome, ASCOM flaps, and everything. So even ASCOM some rain sensor or something like this. So SIPS accepts ASCOM drivers for all devices, from cameras to mounts to everything else. Yeah.
Nice.
I'm really intrigued with this. And Pete, I want to say thanks, for having Pavel on, because I had no idea about SIPs, but I'm kind of intrigued about the software myself personally. So I'm actually going to download this to my little Melee PC, and next clear sky we get, I want to give it a spin.
Yeah,
I'd like to just personally just give it a spin and give it a shot.
Yeah, and as I said, any feedback is appreciated. So,
I got my Eagle 5 still wrapped up in the box. I haven't even taken it out yet, so maybe I'll throw it on there and see what we got. Because I got 3 mounts in the backyard, so I'll throw it up on one of them and see.
Yeah, and definitely. I'd love to, like I said, I want to, I'm learning new software, to move away from maybe, the ASI Air. So I'd like to give this a try, something new to try. I'm always up for new stuff.
Absolutely.
Yeah, currently available is only version 3. It's kind of outdated because version 4 is in alpha version. It's also possible to download the alpha version. You can, it's a bit confusing because you go to the beta version folder and download alpha version of new SIPs, but there will be first the beta will be out pretty soon, I believe within a week or two, and but the final release date of version 4, I hope this summer, but we will see how it depends.
Software could be kind of scary sometimes. It'll work one day and all of a sudden we got to figure out what bug that's from.
Exactly.
So it's all about troubleshooting. It's all about getting out into some of the users that actually know what they're doing. And you got to get the people that try and break stuff. You know what I mean? So what happens if I do this? Okay, what happens if I do that? And not just do a regular sequence, even though that's part of it, but see what happens, because you know what? Some people out there just like to play around and hit buttons. And you got to have that same type of mentality when you're troubleshooting, whether it's your mount or software. You gotta think every single type of contingency of what would happen and get it fixed.
It's very useful to have such people among testers. That's
absolutely. You must have somebody that knows how to break stuff. Hey, listen, me and Eric talk about it all the time. We were doing computer repair back to 5.25-inch floppy drives. So we were sitting there playing with that, and I would take it apart, and I'd look at it, and when I'm done putting it back together and it works, I got like 4 or 5 screws or so in my hand that I don't kind of know. Well, it works. So we don't need those.
Nope.
So
Yeah.
But let's
Awesome.
see.
Yeah.
What else we got in the chat? Anything in Eric's chatting away in the chat.
Yeah, you know me.
Yeah,
I'm looking forward to it.
It looks like we peaked at about 40 people on the live show, so that's pretty good. Looking pretty good for the live show. And let's see. We do have a couple of giveaways, right? I think we got to do that. We got to do picture of the month.
Yep.
I don't know if you know this,
picture.
Pavel. We do picture of the week, and our members submit their pictures, and they get voted on by their peers. And we do a picture of the week every week, and at the end of the month, we do a picture of the month. Whoever wins picture of the month goes in the AstroWorld. I don't think I have them with me. No, yeah, I do. I have last year's calendar here. This is last year's calendar, and they get put into a calendar, and every picture of the month is hosted in the calendar. So
Yeah.
So that's what we do. So we do we start in December so we can get the calendar out on time, and then we sit there and we do lots of stuff. So we do that once a week. It's all on the website, and then after that we do a little bit of a giveaway for the Masters of Pixinsight class. And is that it? Am I missing something?
Yeah, no. I mean, yeah, that's it. But that's not it, because we've got, some awesome guests. We have Pavel here from Moravian, and I only see 26 likes.
Oh, it's 27 now.
I only say 27? Really?
27.
And we had 32 watching. Yeah, something's not right there.
We had 40 watching.
So I'm just saying.
28. All right, come on, guys.
Come on now. I mean, you guys are gonna get you guys are gonna get in trouble. I'm just letting you guys know.
Someone's gonna log off and make it 33.
Pavel's taking time out. It's 2:00, 3:00 in the morning, and he's taking time out to do this stuff for us. And you guys don't give us a like. Come on.
There we go. We got 32 for 32.
There we go.
Man, it don't happen unless you don't ask. You got to ask.
Exactly. I'll go get Titan. I'll go get the pit bull on you guys. Come on.
Oh, geez. We don't want that. Woo. Unbelievable. But yeah, so all right. So I guess you want to take a look at the pictures real quick? We can take
let's take a look. Let's take a look at these pictures. Let's see, what our esteemed, audience and viewer membership have given us.
Let's see. Display 2. There we go. And where did Pavel go? What happened to Pavel?
Did you put him behind me, or did you put him behind?
I think he's behind Pete.
I bet he's behind Pete. Don't do that to Pavel. Put him. You got to give him his own space here. No,
not behind Pete.
Where is he?
Oh, I see what happened. I got you, Pavel. Give me 1 second.
All right.
I see what happened. We'll get Jesse out of there because Jesse's not there. There you go. And guest. And edit. And
there we go. There we go.
There we go. All right. So this is our website here, and you're gonna have to excuse the slowness of the loading because some of these pictures are really, really, really large files. So, so our last picture of the week, we had a tie. So we got May 5th was Dave Schaefer's M106, and Jason's M13. So nice job to you guys. That's our last picture of the month for March. Ryan Nebula. So nice job with that. That was done. What is this done? With a ASI 294 on an AT72. So small scope, really nice. Nice detail in the clouds. So that's why it won. So this is the current pictures of the week. So here we go. Dave Shaver's, I'm going to call it the flaming skull again, because this one really looks like the skull, you know. So
this one,
it's the rosette.
It's not the rosette to me anymore.
No,
Thanks,
no.
You know, so again, thank you to Tegan for putting this into my head, and it'll never be the Rosette Nebula for me ever again. This is the Skull Nebula.
So Pavel, what would do you see the skull? Because you look like you're a little confused.
Luckily, I see Rosette. Yeah, only I don't see the skull.
Okay, so we'll point it out to you. Here you go. So here is an eye socket. Here is another eye socket. There's the nose. There's the mouth, and there's the head.
Now I can see it.
And you will never unsee it.
You'll never look at the same way again.
You'll never look at it the same way again.
Kind of scary, yeah.
No, it's a little odd looking, but you know. And then we got the flaming star and the tadpoles.
Yep.
That was Josh Kovac. That was done with the Red Cat and MBZ.
Very nicely done. Very nice.
Then you got Mark Ellis's M51. This is done with his, was it CDK12 and his L350 out in Arizona somewhere. So
he just put down no stats.
I still think he bleached it a little bit. Sorry, Mark. I hate to tell you, it looks a little bleached. I don't know. A little bit on the needs a little bit more blue. Needs a little bit more blue to me, but you know that's okay. Beautiful job on the dust lanes. Nice job. And then you got I don't know who the name of this is, but this is the Altair 60 wide field of the iris. Great job with the cloud and the dust all around. It's beautiful. So we had only 26 votes this week. We usually over 80 or 90, and I don't know. I think everybody's still on NEEF hangover. I think I'm gonna blame it on that. But you know, 26 people, and you know what? 9 of those people came tonight on the show because it was 17 when we started the show, so it was pretty low. So for you discard users, for your if you follow us on Facebook, you follow us on YouTube, whatever, please log in on Mondays or Tuesday mornings, and the voting starts on Tuesdays. All right. And Pete's watching the game. He's like, I can't do it no more. but so here we go. So let's take a look and see who won picture of the week. And where did I put my all polls? Here we go. And picture of the week ending May 12th, 27 votes now. And the winner is the Rosette / Flaming Skull with 12 votes. So
there we go.
So followed by the Iris with 7 votes.
All right.
Mark Ellis is M51 with 4, and Josh Kovac with 3. So nice job to Dave again. So beautiful job, man. Congrats. Absolutely.
All right. So now we've got what, the L Extreme?
No, we're not doing that. Did we say we were doing that tonight?
Oh, wait. Did say that.
We said we were going to do that tonight, and it was only people that were watching the show, right? And I was going to write the number on the back, right? Because we didn't want to give it away. Here it is. 2-inch L Extreme from Optolong. Right there. Okay, so we're going to do this right now. And I'm going to write the number down. Okay? And I know you got to be fast on the trigger, guys. So we're watching the chat. You No, don't put your numbers down yet until I say go. All right, and here we go. So I'm gonna put a number from 1 to well, we got 30 people watching, so we'll do 1 to 30. How about that? All right.
There you go.
So I'm gonna put the number down here and go. No. Dave, nice work. No. 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 Everyone, I love doing this. People doing the same number. Nothing yet. Nothing. Oh my goodness. Oh, stop. Terry Martin. Number 12. Terry Martin. Number 12.
Congrats, Terry.
Terry Martin. Send me an email at Dan. I'll put it in here. Dan at AstroWorldWeb.com. And send me your address, and I'll put this in the mail for you. So Christmas comes early to Terry. There you go. Congratulations.
Congrats, Terry.
You just won
Nicely
a $300 filter. There you go. Merry Christmas.
There you go. Nicely done. Cheers on that.
55.
Right.
It's 1 to 30, Dan. Come on. Somebody's been hitting the wine, but
yeah, I know. And he said 25. He went back to 25.
Oh.
I know. But hey, anyway, Norm, it's over. It's over, Norm. You can't hit 12 now.
Yeah, I looked back, and Terry Martin was the winner, 12. So
That's
so.
It. All right. Anything else?
Sorry, Norm. Sorry, Newman. Oh, so really great show. Oh my goodness. Yeah. The Leafs tied it up in the third. Oh my God.
Down 2. Oh yeah, baby. Oh!
I guess they just called.
Oh baby.
Did they?
Oh God.
I love it.
Is that 3?
I'm a hockey fan from Toronto.
Yeah.
Oh, that's amazing.
All right then.
Is that 3 or is that 2-2?
2-2, man. We go to OT now.
Oh, you're far behind. I've had that on my phone for like a minute.
I know.
I said they tied it up 2-2 before you got up.
I know, because that was just it. It just got in there.
Damn West Coast people, they're always behind.
Oh, that's amazing.
Awesome. Well, Pavel, thank you. So I know it's late over by you, and I want to say from the bottom of my heart, thank you for coming on and spending some time with us and hanging out with us and teaching us a lot about your camera line. And I know a lot of people are fans that were in the chat. I know Mark Alice is drooling at that. He wants to put something on the back of his CDK. So but thank you so much for coming on and hanging out with us. It means a lot. Thanks.
It was my pleasure to be here with you, virtually with you, but it was a great. Thank you for inviting me, and maybe if sometime in the future you want to talk about SIPs, probably when the version 4 is out.
Yeah.
So
and if you want, we've done this before. We've done like Saturday shows for our guests from Europe that we could do during the day. That's not 3 o'clock in the morning. So
we can definitely be flexible for that.
Absolutely. We've done it for many guests before. It's just we all have lives. But just staying up all night sometimes is not good for the little internal clock sometimes, even though that's part of what we do.
It is not. After all, we are astronomers, so we used to stay awake in the night. Yeah.
Yes, we do.
Okay.
But we usually do a final thoughts, and I know Pete's final thought. Pete's ready to go because he's got 3 minutes left in the game. He wants to go catch the end of the game. But we'll do Pete first so he can get out of here. So Pete, final thought.
Pavel, sincerely, an appreciation for taking the time to come on the show. I've always been a proponent of your cameras, and thank you for coming on as being a guest. And definitely with SIPS 4, I look forward to it because it is a great software, and I highly recommend it. So thank you for taking the time, and look forward to having you come back on here in a month or so.
Yeah. Okay. It was my pleasure.
Again,
Really.
thank you.
All right. All right,
Okay.
everybody. Well, thank you again. And don't forget, thank you so much for coming on. We got Wednesday night, we got Warren Keller coming on to do part 2 of his M51 workflow. You're not going to want to miss that. Eric, do you have anything, final thought you want to say?
No, again, Pavel, thank you so much. And again, everybody, thank you for your continued support of the show and AstroWorld. We really appreciate that. And have a great weekend. Be safe. Happy Mother's Day to all the moms here in the U.S.
Totally forgot about
Mother's
that.
Day. So, and around the world, happy Mother's Day to everyone, to all the moms out there. So we couldn't be here without you. That's for sure.
Yep, absolutely. And why is work calling me at 10 o'clock at night? But
Oh boy.
yeah, it's not real work. They call me from the Philippines. But all right, Pavel, would you like to some final thoughts? Would you like to?
Yeah, it was a great experience for me. Yeah, probably it could be difficult to understand my English, but it's only second language, and hopefully you could understand a lot more important things. And it was really great. I'm really happy that I could introduce our company and our cameras because we love astronomy. We do astronomy. We do it for astronomers, and if we do not love astronomy, we could hardly do such things for a living. We would choose something different. But so
Yep.
it was a pleasure to be with people who also love astronomy and observe universe. And okay, maybe see you sometimes in the future.
Yeah,
maybe more
when 4 comes out, we'll definitely have you back and do a little work on SIPs. It'd be a lot of fun.
Yeah, absolutely.
All right, Pavel. Well,
Okay.
again, have a good night. Thank you so much. Thank you, guys. Eric, Pete, Pavel. Thank you, everybody. Pete, you got 1 minute left to watch the game. And everybody, remember, keep imaging, keep educating, and clear skies. And we'll see you Wednesday night. Have a good night, everybody.
See everybody.
Bye.
Have a great weekend.
Bye-bye.